आप सब बढ़िया, एकदम मस्त, एकदम ढिंचाक। हाय माय डियर साइंस लवर्स, सॉरी फॉर द डिले। स्टूडियो अवेलेबिलिटी नहीं थी, स्टूडियो खाली नहीं हो रहा था, इस वजह से मैं लेट हो गई आज की क्लास के लिए, जो कि है ज्योमेट्री की क्लास, राइट। ज्योमेट्री, तो हम केमिस्ट्री में भी ज्योमेट्री की बात करते हैं, बट फॉर मॉलिक्यूल्स। आई होप आई एम ऑडिबल एंड विजिबल। जल्दी से बता दो, छोटा सा प्यारा सा सेशन है, बहुत जल्दी खत्म कर दूंगी, राइट। सो ज्योमेट्री क्लास फॉर मॉलिक्यूल्स, आपको अगर पता है, if you are following B2A series for your NSEJS preparation, you know in the last session we learned about the shapes of molecules, covalent molecules, valence shell, electron pair repulsion theory, right? And I went to a bookstore, Crossword, to buy some book, and मुझे दिखा एक रूबिक क्यूब का न्यू वर्जन, राइट। सो दिस इज अ रूबिक क्यूब बट पिरामिड। सो जैसे ही मुझे ये रूबिक क्यूब पिरामिड दिखा, सो वैसे ही मेरे दिमाग की घंटी बजी कि यस, आई एम टीचिंग यू गाइज द शेप्स ऑफ द मॉलिक्यूल, and the most common shape is tetrahedral shape, the shape of CH4, right? And where the tetrahedral shapes come from, this tetrahedron pyramid, it has 4 faces, right? So just to show you guys, I bought this molecule ka, not exactly, this is not a molecule, it is a Rubik cube ka like pyramid version, right? But yes, this is a tetrahedron, this is a tetrahedral shape, guys. You can see the different 4 faces, the different colors, right? Okay guys, so today I am going to tell you in part 2 of molecular geometry that if there is a lone pair around the central atom, what will be the shape of the molecule, how your covalent molecule will look like. So let's see quickly whether you remember the last session or not, guys. Yes, so today we are going to play with the molecules, their molecular geometry, right guys? Okay, so in the last session, if you remember guys, if you have 2 bond pairs, because in the last session we did only about the bond pairs, we took only those molecules in which there is a bond pair around the central atom. And this theory says that there is a central atom and the central atom will acquire that shape so that the electron pairs around the central atom, they are as far as possible so that your molecule can be stable with least repulsions, right? So valence shell electron pair repulsion theory. Covalent molecules have different shape. Why certain molecules have a certain shape? Why your CH4 is tetrahedral like this? I just show you guys, right? Because by keeping its 4 bond pairs, 1 bond means 2 electron apart at 109.5 degree, there will be the maximum distance between electron pairs and less repulsion that makes your molecule stable, guys, right? So let's see, today you are going to have fun in this session, guys. So if there are 2 bond pairs around the central atom, what is the geometry? Linear 180 degree bond angle. I hope you remember. 3 bond pair we did trigonal planar. Trigonal planar is the geometry, 120 degrees the bond angle. If there are 4 bond pairs, 4 bonds around the central atom, then it will be tetrahedral shape, right guys? 109.5 degree bond angle. If there are 5 bond pairs, 5 bonds around the central atom, no lone pair, then it will be trigonal bipyramidal. I hope you remember triangle above and below, and 6 bond pair around this. There will be octahedral shape, all angles 90. Octahedral shape, and 7 bond pair around the central atom, that will be pentagonal bipyramidal. In between there is a pentagon above and below, right? This we did in the last session, VSEPR. Now part 2. Today we are going to know the shapes of those molecules which have lone pairs also, right? Let's quickly see those molecules, guys. Let's see. Okay, suppose I have SnCl2. This is the molecule, right? So what is the central atom, guys? Sn is the central atom, 10. 10 belongs to group number 14. That means it has how many valence electrons? It has 4 valence electrons around it, right? And out of 4 valence electrons, 2 are making bonds with the central atom, right? That means we have 2 bond pair around the central atom. Central atom is 10. And we have electron pair, 1 electron pair which is not participating in bonding. We call it lone pair, right? So we have 2 bond pair 2 electron pair of bonds and 1 lone pair around the central atom. That means total we have 3 electron pairs around the central atom, right? So we have 3 electron pairs. So how the 3 electron pair will arrange around the central atom so that there is a maximum angle between them? 120 degree. Of course, they will be at 120 degree, right? They will arrange like 120 degree, like triangle shape. But how the molecule will look like? Because this is an electron pair, the lone pair is electron pair inside the atom. It's not a bond pair. So this molecule will look like this only, no? This is the central atom, these are the two side atoms. So if there is one lone pair and 2 bond pair around the central atom, the molecule will look like bent shape or V shape, we call it. So it will be bent shape or V shape. How the molecule will look like, guys? Bent shape, like this. Because this electron pair is inside the atom, it is not giving it any particular shape. So when you have 2 bond pair, 1 lone pair, it will be bent shape or V shape. Now what will be the bond angle? Will it still be 120 degree? No, ma'am. Because you know, in the last session we studied, this lone pair will repel this bond pair more. So this lone pair, because it is free, electron density is there, it will repel those bond pair electron. So they will feel repulsion from above and they will like this. So this angle decreases, it will become less than 120 degree. Yes, got it, guys? So this is V shape, bent shape when you have 3 electron pairs, but out of 3, 1 is lone pair, 2 are bond pair, right? Now let us take those cases in which there are 4 electron pairs around the central atom. If there are 4 electron pairs around the central atom, the shape that molecule will acquire is this. This is the tetrahedral shape, right? Tetrahedral shape. I showed you the last time this molecule. This is a tetrahedral shape. There is a central atom and there are 4 bond pairs. And what is the bond angle here? Between the 2 bonds, 109.5. This is the tetrahedral shape, guys. So now let's see if out of 4, 1 is a lone pair. Let us take the very common. Now the cases that I am going to take, they are very common, guys. Ammonia. You should know, questions have been asked in NSEJS on this, right? Ammonia, central atom is nitrogen. 1, 2, 3, 4, 5, right? So we have 5 electron pairs around the nitrogen. Out of 5, 3 are the bond pairs and this 1 is a lone pair, right? So out of 5 electrons, 1 is a lone pair which is not participating in bonding and 3 are bond pairs. Total we have 4 electron pairs around the central atom, 3 bond pairs and 1 lone pair. Now they will arrange tetrahedrally. The geometry of the molecule is tetrahedral because 4 electron pairs, they can have maximum angle 109.5 degree. So they will arrange like this only. But how the molecule will look like? So this is the tetrahedral shape, guys, see, right? If all the 4 are bonds. Now let's see, there is only 3 bond, 1 electron pair is inside the atom. So now this shape, because 1 is the lone pair, this is inside the atom. Now the molecule looks like this. What shape it is? So we call it trigonal pyramidal shape. So if there is 1 lone pair and 3 bond pair, the molecular shape will be trigonal pyramidal, right? It will be trigonal pyramidal, right? Now let's take the example. So now let us take the example of H2O. So H2O, again central atom is oxygen. Oxygen has how many valence electron, guys? 1, 2, 3, 4, 5, 6. And in water molecule, 2 hydrogens. 2 electrons of oxygen are making bond with hydrogen. And we have 2 lone pairs here, right? So around oxygen, we have total 4 electron pairs. Out of 4, 2 are bond pairs, these bond pairs, and 2 are lone pairs. So the 4 electron pairs, obviously they will arrange. How they will arrange? Tetrahedrally. But how the molecule will look like? Because the molecular shape depends upon the bonds, right? So now out of the molecule remain like this, tetrahedral, 2 bonds are gone. It will mean like this. This is a V shape or bent shape. This is the shape of water molecule. So the molecule will look like V shape, or you can call it a bent shape, right? Got it, guys? Yes, molecule will look like this. Now let me compare all the three cases here. Which cases? CH4. All 4 bond pairs, the shape is tetrahedral. No lone pair, only 4 bond pair. The bond angle is 109.5 degree and we call it tetrahedral geometry, right? All bond pairs, no lone pair. Now, if out of 4, 1 is lone pair, so out of 4, there is 1 lone pair, rest 3 are bond pair like in ammonia. The shape is trigonal pyramidal, right? Trigonal pyramidal. Now the molecule will look like trigonal pyramidal and the geometry, of course, they will arrange like tetrahedral only. Now the bond angle, what will be the bond angle here, guys? Because this lone pair repel the bond pair and this bond angle, which is ideally 109.5, it decreases to 107 degree. So you should also know the bond angle in ammonia, right? Now let us take the third case, H2O, where I have a central atom with the 2 lone pair and 2 bond pair. That means total 4 electron pair. So here there is no lone pair, here there is 1 lone pair and here there is 2 lone pairs. Now lone pair will also repel each other more, right? So now this angle further decreased to 104.5 degree. Got it, guys? So that angle further decreased to 104.5 degree because of more repulsion between lone pair, lone pair. And the molecular geometry is, this is the bent shape. So this question was asked in NSEJS. You should know all bond pairs, 1 lone pair, 2 lone pair, how the molecular shape, how the molecule will look like. Got it? Yes? Clear? So you should also learn the bond angles here, guys. Let me show you something really interesting. Okay, so quickly. So I have this molecule. So let us take CH4 first, right? So this is your CH4, guys. This is the CH4. This is tetrahedral shape. CH4, all bond pair, there is this carbon as a central atom. And there are, you can see this molecule, all, right? Bond angles are 109.5 degree. All, any 2 bond you can pick, the bond angle is same. Now, if there is 1 lone pair, that is, it is ammonia. So this lone pair and 3 bond pair. Angle is 107 degree. So this is a lone pair. These are the bond pairs and how the molecule will look like. How the molecule will look like, because this is electron pair. This is inside the atom. The molecule will look like trigonal pyramidal with 107 degree. So this is a triangular pyramidal, right? A pyramid with a trigonal base. Just like this. A pyramid with a trigonal base, right? Pyramid with a triangle base, like this. This is ammonia molecule, trigonal pyramidal. This is a pyramid. So there is this nitrogen is here. Nitrogen, hydrogen, hydrogen and hydrogen. Pyramid like this. Hi guys. Right? Now let me show you H2O. Where is H2O? So H2O, Pani. It has 2 lone pairs and 2 bond pairs. So this is water molecule, guys. 2 bond pairs and 2 lone pairs. So your oxygen, 2 electron pairs, they are not participating in bonding. 2 are participating in bonding, guys. Right? You can see. Yes. So how the water molecule, 4 electron pairs around the central atom, you can see out of 4, 2 are lone pair and 2 are bond pair. So this is the shape of the water molecule, guys, because lone pair, they are inside the atom only. V shape or bent shape, 104.5 degree. This is the shape of the water molecule. Got it, guys? Water molecule, you can see. You can rotate it, 100. This is bent shape or V shape. Got it? Yes. So this is the shape of water molecule. So why water molecule has V type shape? Why ammonia is pyramid type shape? Why methane is tetrahedral? We have all answers which are hidden in this theory, valence shell electron pair repulsion theory, which says the shape the molecule acquire is to minimize the repulsion between the electron pairs around the central atom, whether they are bond pair or the lone pair. And lone pair repulsions are maximum. They repel a lot. Then bond pair, lone pair, and then least repulsion between bond pair and bond pair. Got it, guys? Yes. Okay. Let's quickly move ahead. So, this is the shape of the water molecule, guys. That is bent shape or V shape, right? Okay. Now, suppose I have 5 electron pairs around the central atom, as I told you, the case of PCl5, all are bond pairs. So, if you have 5 electron pairs around the central atom, so the shape of the molecule is what? Trigonal pyramidal. TBP, trigonal pyramidal, right? So, there is a triangle, and at the center of the triangle, there is a central atom above, below, and on the vertices of each, there is an atom, side atom, right? Central atom is phosphorus, and we have 5 chlorine around it. These bonds are known as equatorial bonds having angle 120 degree. Above and below, they are known as axial bond having angle 90 degree. We studied that in the last class, guys. Yes. Now, let us take the case of SF4. Now, the central atom indeed is sulfur. Sulfur, how many electrons? Valence electron, it has 6. 1, 2, 3, 4, 5, 6. And out of 6, it is forming bond with 4 fluorine. Each fluorine is sharing electrons. So, we have 1 lone pair which is not participating and 4 bond pairs around this central atom. So, what is the central atom? Sulfur. So, sulfur has 1 lone pair and 4 bond pair. So, out of 5 bonds, 1 is now a lone pair, right? Geometry is like this TBP. But how the molecule will look like? What is the shape of this molecule you call? This electron pair, forget it. This is not, it is inside. So, what you call this shape, guys? K shape, or do you remember the seesaw? Seesaw in the park, once kids sit here, one sit here, this seesaw, right? So, this is the seesaw shape. So, when you have 4 bond pairs and 1 lone pair around the central atom, that shape is a seesaw shape, right? That is a seesaw shape. Now, let us take another example, ClF3. We have chlorine, and chlorine has how many valence electron? 7 valence electron, and out of 7 valence electron, chlorine is making bonds with 3 fluorine, and it has 2 lone pairs around it. So, total 5 electron pairs, and out of 5, 2 are lone pair and 3 are bond pair. Now, total is 5. So, they will arrange like this only. But how the molecule will look like? These are the electron pairs. They are not bond. So, the molecule look like this. What do you call this shape, guys? That is a T shape. Right? That is a T shape. T. 2 lone pair, 3 bond pair around the central atom. That is the T shape. Molecule will look like T shape. So, PCl5 molecule, trigonal bipyramidal. SF4, it will be seesaw. ClF3, T shape. And suppose if this is also lone pair, this is also lone pair, suppose, then the molecule will be linear. So, if I have 3 lone pairs and 2 bond pairs around the central atom, 3 lone electron pairs and just 2 bonds, total 5 electron pairs, but out of 5, 2 are bond pairs. So, the molecule, this is also lone pair now, linear. In that case, it will look linear, right? Let me show you again these molecules. Okay. Now, let us take the case of PCl5. So, this is PCl5, guys. Trigonal bipyramidal shape, TBP. This central atom. I hope you can see, guys. This is this central atom. This is the central atom, phosphorus. This is a triangle. This is above and below. Trigonal bipyramidal, TBP shape, right? This is a TBP shape of PCl5. Phosphorus, chlorine, chlorine, chlorine. Got it? Now, suppose out of these, 1 is the lone pair. Now, out of this, you can say, this is the triangular bipyramidal shape, 1 is lone pair now. On triangle, 1 is lone pair. So now the molecule, how the molecule, this is a lone pair, it is inside the sulfur atom, SF4. This shape is seesaw shape. Can you see the seesaw shape? There's 4 bonds, 1 lone pair. That electron pair is inside the central atom. Yes? Shreyas, you need to watch VSEPR, the last session. If you have no idea of VSEPR, then all of a sudden you can't get the things. Shreyas, it is advisable. Please watch the part 1. This is pretty easy, very interesting. Right? Just make sure that you watch that session, because you should know that PCl5 is TBP, that I explained in the last session. And if on trigonal bipyramidal, I keep 1 lone pair, 1 is the lone pair, so molecule will look like, so in SF4 we have 5 electron pairs, and out of 5, 1 is a lone pair, 4 are bond pairs. So how the molecule will look like, the shape of the molecule is seesaw, because this is electron pair. What is a lone pair? That electron pair of valence shell which is not participating in bonding, that is the lone pair. So this electron pair is inside the atom, right? Yes? Great. So this is a seesaw shape. Can you see? This is a seesaw shape. This is seesaw shape. Seesaw. Do you know what is a seesaw? That swing in the, that, park, kids sit. So it looks like this. Suppose one, again, this is the shape. Suppose I take 2 lone pairs, right? Suppose out of 1 bond, this is also lone pair. Let's take ClF3. In ClF3, we have 2 electron pairs, that is lone pair, and 3 bond pair. So this is a triangle. In triangle, there is just 1 bond and 2 are electron pairs, lone pairs. So how the molecule will look like, guys? T shape. This is the shape of the molecule, T shape. Can you see this is T shape? This is, the shape is defined by the bond pair, right? T shape. Yeah, it is 3D. Yes, it is T shape. ClF3 molecule is T shape. Let me remove the electron pairs. Now, can you see this is a T shape molecule? Total 5 electron pairs, but out of 5, 2 are lone pairs, so they will not define the shape. So shape is defined by the bond pairs. How the molecule will look like depends upon the bonds, right? So this is a T-shaped molecule. Got it, guys? Yes. Now, let us move ahead. Now, if I have SF6, that is SF6, if I have 6 electron pairs around the central atom, the molecular shape is octahedral. I taught you in the last class, this is octahedral shape, guys. All 90 degrees. There is a square in between, square above and below, and the bond angles are 90. This is octahedral shape, right? This is octahedral shape. Can you see this is octahedral? There is a square. This is the central atom sulfur, 6 fluorine. All the 6 electrons of sulfur are making bonds. No lone pair, all are bond pair. 6 electron pairs, how they will arrange themselves to minimize repulsion? By keeping themselves at 90 degrees. So this is octahedral shape, guys. Octahedral shape. Now suppose out of 6, there is a lone pair. Bond is replaced by electron pair. There is no bond, only electron pair, right? Suppose I have this. So out of 6 bonds, 1 bond gone. Just we have 5 bonds now. How the molecule will look like, guys? What do you call this shape now? Now this lone pair is inside the atom, that will not define the shape. What you will call this shape, guys? This electron pair. What do you call? Only 5 bond pairs. One is the electron pair inside the central atom, BRF5. What do you call this shape? But in 5, it makes an angle of 90, 80 and 120 degree. What is that? Yes. So what do you call this shape, guys? What do you call this shape? This shape is square pyramidal. There is a pyramid whose base is a square, right? So this is a square pyramidal shape. So if there is 1 lone pair and 5 bond pairs around the central atom, total 6 electron pairs, they will arrange octahedrally only, right? You can see the arrangement. They are octahedrally arranged. But how the molecule will look like? Because this is a lone pair, the molecule looks like square pyramid, right? Square pyramidal shape, a pyramid which has a square base. Because one, see guys, this was the octahedral shape, right? This is the octahedral shape. Now this one is gone, only above. This is a square and above. This is square pyramidal, right? Okay guys, and suppose two lone pairs are there. Suppose out of 6, above and below, this is a square, above is also lone pair, below is also lone pair. What remains? What the molecule looks like? Square. So if there are two bond pairs and two lone pairs and 4 bond pairs out of 6, the molecule is square shape, right? Just the case in XEF4. Xenon has 8 valence electron. Out of 8, it is forming bond with 4 fluorine. That means 4 bond pairs and 2 lone pairs. What is square planar? Very good, Shukla Das. It is square planar shape. Well done. Suppose this is also lone pair. Suppose this is also lone pair. Suppose this is also lone pair. Then you will call it T shape. If this is also lone pair, what you will call it, ma'am? It will be V shape. Right? Yes, the shape is defined by the bond. Right, fine? So, these are the shapes of the molecules having lone pair that you should know, right? So, you should know these molecular shape along with the bond angles, especially the cases I took ammonia, right? I took CH4, I took water. They have been asked in NSEJS previously. You should know VSEPR theory. If there are no electron pairs around the central atom, plus if there are lone pairs around the central atom, you should know the shapes of the molecule, guys. Right? Very, very important, very basic, fundamental. So you should all know. Right? So this, which shape is this? Pyramidal shape is this? Bent shape is this? Right, guys? So you can see here how many electron pairs, how many bond pair. Examples are also given. This is also given in NCERT class 11. So what shape? How many lone pair? This is seesaw shape, right? If there are 1 lone pair and 4 bond pairs, the molecule is seesaw. Yes, I am not getting your doubt. What exactly are you asking, Shreyas? Can you elaborate your doubt, Shreyas? So this is T shape, guys. Octahedral shape, you know, all know, right? This is square pyramidal, right? If 1 lone pair and 5 bond pair, and if there are 2 lone pairs, then we have this square planar shape. Yep. Got it, guys? Okay. If there are 5 bond pairs around CS, the central atom, the bond angle is not 90, 80, 120. It is 90 degree and 120 degree. Trigonal bipyramidal, that is. Right? So guys, VSEP are very, very, very important to know the shapes of the different molecules, right guys? So those who are, and also please remember in VSEPR theory, we treat double or triple bond as a single electron pair, as a single bond pair, right? So you treat double or triple bond as a single bond pair. Got it? Yes. So please tell me the shapes of these molecules. What are the shapes, molecular shapes of these molecules? One more thing I want to tell you guys. If I ask you, what is the molecular geometry of ammonia? So ammonia has 4 electron pairs, 1 lone pair and 4 bond pair. So geometry of this molecule is tetrahedral, because total electron pairs, how they are arranged, lone pair and bond pair, how they are collectively arranged, they are arranged tetrahedrally. Of course, 4 electron pairs will arrange tetrahedrally to minimize the repulsion. But if I ask you, what is the shape of this molecule? How this molecule will look like, because one is a lone pair, this is electron pair only. So this molecule will look like this only. So that is trigonal pyramidal. So what is the difference between the two? Molecular geometry and the molecule shape, electron geometry and molecular shape. Electron geometry means the total electron pair, lone plus bond, how they are arranged around the central atom to minimize repulsion. And shape means the arrangement of bond pairs around the central atom, how the molecule is looking like. Got it? Yes. So please make sure that you know these two things. So ammonia, the geometry, electron geometry is tetrahedral, whereas the shape of the molecule is trigonal, pyramidal. Yes. Okay. Just चलो अब कुछ क्वेश्चंस मैं देना चाहती हूँ फॉर योर प्रैक्टिस ऑन VSEPR. Predict the shapes and geometries of these molecules. What will be the shapes and geometries of these molecules? Shape. You need to tell me the shapes of these molecules. That will give you a good practice, guys. H2S, CO2, BCl3, BeCl2. Some has electron lone pair, some has lone pair and bond pair both, some has only bond pair on the center. Predict the shape of these molecules, guys. If you can do these questions now, that means you have become pro in VSEPR. So this is for your practice, guys. Right? Just practice. See these two sessions, very short sessions I took so that you can watch this session. VSEPR, valence shell electron pair repulsion theory. This week in B2A series, last week in B2A series. Just two short sessions and you'll be able to predict the shapes and the molecules of the geometries of all these molecules, right? So just quickly note it down in your notebook if you can answer these. And please keep in mind that oxygen forms double bond with the central atom, right? And you just need to take double bond as a single electron pair, single bond pair, right? So these are the molecules, and if you practice these molecules, their shapes and geometries, that will be sufficient for VSEPR. Got it? Take the note, guys. Practice these molecules. XeOF4. Right, guys? So if there is any student who is in class 10th, please keep in mind, and this is also homework question if you can answer me, right? You can answer this in the comment section, guys. This particular SCl4, what should be the shape of this molecule? SCl4. Okay. And a good thought to share. A goal without a plan is just a wish. So if you have certain goals in your life, cracking some exam or whatsoever it is, have a plan for it, right? So if you are targeting NSEJS exam this year, a newly launched exam, highly competitive exam on the lines of NTSC, especially 10th or 9th graders, 8th, 9th, 10th graders, I will say, this exam you should not miss this year because this is going to be a game changer in your life. NSEJS exam in English, it is going on. The batch is in English. You can be a part of this batch. We just started. We just have 1-2 sessions in the batch, right? 120 live sessions, physics, chemistry, biology, and maths, right? So this is the batch, guys. Also, free NSEJS test series is included in the batch. Whosoever is buying this batch will get a test series of NSEJS absolutely free. So hurry up, guys. Do not delay your preparation. Batch timing is 7 to 9, Monday to Thursday. Just 1 hour commitment. Friday, Saturday, because mostly schools are off on Saturday and Sunday, 2 hour commitment. SPHS batch, quite manageable with your school and with your ongoing batches. So hurry up, guys. If you want to clear SEHS exam, if you want to attend the camp, zonal camp, right? The offline camp conducted by the best teachers of country in science, theory experiment. If you want to be there, clear this exam, and to clear this exam, you should not. So, as I just told you, wish without goal without a plan is just a wish. So, if you have a goal to clear this SEHS exam among the top, you want to be among the top students in India in each zone, right? So, if you don't plan it, if you don't work for it, it is just a wish, right? So, just plan for it, and I'm sure this batch is quite manageable, and even if you cannot watch the live session, you can anytime watch the replays. 1 hour session replay is very much easy to manage, right guys? So guys, this is the batch price, link in the description box. Check the details guys for 999 English batch. The batch is in English, so anyone who cannot understand Hindi also can be a part of this batch, right? And also the highlight, if you qualify for zonal camp, right? 25 students from each zone will be qualified to attend a camp. You will get 100% refund of your fees. If you are among top 1% national, 50% will give you the fee refund, and if you are among 1% national certificate, you will get 30%. So we want to facilitate your participation in this exam, right? So you can study free. If you are dedicated, you will clear the exam. Be regular in the batch, give the regular test, right? Get the 100% refund. What is better than that, guys? So guys, All India NSEJS mock test series is going on. Anyone who is targeting NSEJS, want to be NSEJS qualifier, one of the most prestigious exam to crack in India in science in 10th and below grades. If you have this target, high time, start giving mock test, and this is one mock test series that is for you guys. So 8,999 you can get. It has 7-part test, very well thoughtfully designed. Each part test has certain topics from physics, chemistry and biology, so that you can analyze which section, which chapters are weaker, right? And we have full syllabus test, just like your NSEJS. Same level, same pattern, same marking scheme, and the same time also, right? So go for it, guys. If you are really serious to crack NSEJS exam, more mock tests now you will give, better you will perform. Bye, take care, God bless you all. Keep learning, keep growing, guys. Take care. See you in the next session, guys.